Hi students, this is your maths teacher Shiva. Today's video is on properties of inverse of a matrix. Before going into the properties, you have to know what is meant by a invertible matrix. That is clearly explained in the previous video. Please go through that video to make a better understanding of invertible matrix. Suppose A is a square matrix of order m or n by n. Then if you do the multiplication of another matrix B, which is also a square of the same order, and if A into B is equals to B into A, and if your result is I, then this B is said to be the inverse of A. A inverse can be written as A. So therefore A into A inverse or A inverse into A is I. This is the this A is said to be invertible matrix, and if you multiply its inverse with that matrix, your result is I. Now what are the properties? The first property, very important, uniqueness of inverse. That means for any square matrix which is non-singular, it will possess only one square matrix for it. So what we say that no matrix will not have more than one inverse. For example, if I am taking two inverses for a particular matrix A, suppose B and C are inverse matrices of A. Then as per the rule, A into B or B into A is equals to I, since B is the inverse of A. Similarly, we assumed that C is also another inverse of A. Therefore, A into C is equals to C into A is equals to I. This is equation number 1, let this is equation 2. From 1 and 2, both are equals to I. Therefore, I may equalize this A into B is equals to A into C. If you pre-multiply A with A inverse, that means if you pre-multiply both these with A inverse, that implies to A inverse of A into B is equals to A inverse of A into C. Now I am applying associative law, therefore A inverse into A into B is equals to A inverse into A into C. Since A is invertible matrix, therefore A into A dash, A into A inverse, sorry, A dash, A into A inverse is equals to, or A inverse into A is equals to I. Therefore this will become I, and this will also become I into C. Therefore, if you multiply any matrix with identity matrix, your result is again the same matrix. Therefore, you are getting B is equals to C. Means even you have assumed that there are two or more inverses for a particular square matrix, those will become equal. Means there will be only one inverse for a particular square non-singular matrix. This is the property number 1. Second property says that if A and B are invertible, suppose if A and B are invertible matrices, then their product A into B is also invertible. That means A into B will also have a inverse matrix. That is, the inverse of A into B is AB whole inverse. That can be written as B inverse into A inverse. This is called reversal law. Why? Because you are writing the inverses in reverse order. That's why it is called reversal law. Even if you have A into B into C, whatever the number of matrices you multiplied which are invertible, then their inverse is also that means the product is also invertible, and its inverse is given as C inverse. From the last matrix we have to start C inverse into B inverse into A inverse. That's why it is called reversal law. Since AB is invertible, their det of any square matrix can be written as like this: det A is not equals to 0. You will find what is meant by det, how to find the value of a det in the further videos which comes under determinants. That A is equals to that is a number, a real number, and A is a matrix. You can assign every matrix to a particular real number, that is called its determinant. Now its determinant should not be equals to 0, and that B is also not equals to 0. When these two values are not equals to 0, their product is also not equals to 0. We know that determinant of A into determinant of B is equals to determinant of AB, which is not equals to 0. You will know these properties in the properties of determinants. Therefore, whenever A into B is not equals to 0 means AB is invertible. First, AB is invertible. You have to find what is its inverse. You know that if you multiply AB, okay, with B inverse into A inverse. Why I am multiplying this? If you multiply any matrix with any other matrix, if your answer is a unit matrix, then the second one is said to be the inverse of the first one. I am going to find the inverse of this A into B. So multiplying with another matrix. By using associative law, you can write this as B into B inverse into A inverse. That implies to, you know, B is invertible means B into B inverse is equals to I. You can write it as I, A into I into A inverse. If you multiply any matrix with I, again your answer is that matrix only, therefore A into A inverse. Since A is also invertible, therefore A into A inverse is equals to I, that is equals to I. So if you multiply AB with another matrix, your result is I, means the second one is called inverse of A into B. Therefore that can be written as A into B whole inverse is equals to B inverse into A inverse. In the another method also, if you multiply B inverse into A inverse with AB, you will get again I. That is also concludes that AB whole inverse is equals to B inverse into A inverse. Third property is, if A is invertible matrix of order n, A dash, that means A dash is transpose, is also invertible, and A dash whole inverse is equals to A inverse whole dash. Since they are giving that A is invertible, automatically when A is invertible, its dat will become 0, is not equals to 0, since A should be a non-singular matrix, which means that its determinant, which is a number, should not be equals to 0. That implies to automatically determinant of A dash is also not equals to 0. Whenever determinant of A is not equals to 0, its transpose will value of determinant of its transpose is also not equals to 0. That means whenever determinant of any particular square matrix is not equals to 0, that matrix is said to be non-singular and there exists inverse for it. That means it is a invertible matrix. And also we know that A is invertible matrix, therefore A into A inverse is equals to I. If you do transpose on both sides, A into A inverse whole dash is equals to I dash. This is the property of transpose of a matrix. You may watch properties of transpose of a matrix in the previous video which I done already. Now this is A into A inverse whole dash is equals to A inverse whole dash into A dash. See, transpose of I again becomes I. This property is AB whole dash is equals to B dash into A dash. You may remember this, AB whole dash, that means transpose of the matrix AB is equals to product of transpose of B and transpose of A. Similarly, by using that, I am transforming this. First, second matrix comes first, A inverse whole dash into A dash is equals to I. See what it means. Product of two matrices are becoming I. This means this is the the inverse of this one, or this is the inverse of that one. The inverse of this one can be written as A dash whole inverse. The inverse of this one is this. Okay, the inverse of this A dash can be written as A dash whole inverse, which is equals to A inverse whole dash, which is proved. Okay, property 3 says that if A is invertible, then its transpose is also invertible, and hence A dash whole inverse is equals to A inverse whole dash. Fourth property is, if A is invertible and I am taking a constant k which belongs to set of natural numbers, then A inverse whole power k or A power k whole inverse, which becomes equals to A power minus k. Now you know that when A is invertible, its det is not equals to 0. You know that what is determinant of, just we discussed. Now I am taking A power k whole inverse. What does this mean? A power k means A is multiplied k times, means A into A into A into A and so on whole inverse. This is how many times? This is k times. So inverse of this can be written as A inverse into A inverse into A inverse into and so on. How many times? This is also k times. That implies to A inverse whole power k. Since A inverse is multiplied 4 times, you may write A inverse whole power k. Therefore, A power k whole inverse is equals to A inverse whole power k, which you may write as A power minus k also. This is the property number 4. Fifth property is very important. If A is invertible matrix of order n, then A inverse whole inverse is equals to A. Means if you do inverse 2 times for a square non-singular matrix, then you will get back the same matrix again. Since A is invertible, you may write A into A inverse is equals to I. What does this mean? This is the inverse of this and this is the inverse of this. For writing inverse of this, how can you write A inverse whole inverse? That is equals to A. It's very simple. This is also very important property. Property 6 says that if A is invertible matrix of order n, then determinant of A inverse is equals to 1 by determinant of A. This is very important and very easy also. Since A is invertible, you can write it as A into A inverse is equals to I. Therefore, doing determinant on both sides, determinant of A into A inverse is equals to determinant of I. You will come to know this in properties of determinants. Determinant of A into B is equals to determinant of A into determinant of B. That means determinant of A into determinant of A inverse is equals to determinant of any unit matrix is 1. That is equals to 1. So determinant of A inverse is equals to, these two became numbers now, not matrices. A and A inverse are matrices later before, but now after doing a determinant for it, they became numbers. Therefore A inverse is equals to 1 by det A. This is how you got determinant of A inverse is equals to 1 by determinant of A. And also it says that inverse of any non-singular diagonal matrix is diagonal. You have to know what is meant by diagonal matrix first. Any square matrix is said to be diagonal if its principal diagonal elements are non-zero and remaining are 0. See what I am taking, inverse of any non-singular. If you take a matrix, let A 0 0 0 B 0 0 0 C. This is a 3 by 3 diagonal matrix. Why? Because this A, B, C are called diagonal elements and remaining elements are 0. For this type of non-singular diagonal matrix, the inverse will also become a diagonal matrix and it is equals to, suppose if it is A, you are naming this as A, then A inverse is equals to A inverse, invertible matrix also diagonal matrix, and it is 1 by A 0 0 0 1 by B 0 0 0 1 by c. So it's very simple if you have a diagonal matrix and if you want to find its inverse. These are the very important properties of inverse of a matrix. I hope these are very useful to you. If you think like that, please do subscribe to my channel, share it, like it, and we will meet again in the next video. Until then, have a nice day. Thank you very much.